Thank you for joining us for today's presentation, Keys to Managing Large-Scale System Projects, Session 2, Modern Agility for Maximized Organizational Performance, featuring Captain Kevin M. Smith. Today's discussion will explore Captain Smith's ongoing research in the area of dynamic system complexity and implementation strategies with a focus on agility. What is it? How do we design systems that have it? And what tools are helpful to acquire it? This symposium will explore various dimensions of Captain Smith's work, including his IGI Global video lecture series, Intelligent Systems and the Age of the Superfunction. Captain Smith is editor-in-chief of IGI Global's International Journal of Aviation Systems, Operations and Training, and has also edited and authored several other publications in the areas of technology and engineering management. For more information on Captain Smith's IGI Global research, visit our website, www.igi-global.com, or contact customer service at the information shown on the screen. Today's webinar will be recorded, and all registrants will receive a link to view the online recording. After today's presentation, attendees will have the opportunity to participate in a Q&A discussion with Captain Smith. You can enter questions using the chat box located on the bottom portion of your GoToWebinar control panel. Feel free to enter questions as we go, and we will address them at the conclusion of the symposium. If you have other questions or if you're experiencing any technical difficulties, you can also ask me questions through the chat box that way. Thank you for taking the time to join us. Now I would like to introduce our featured speaker. Captain Kevin M. Smith is an aviator, author, speaker, and a recognized expert in the field of critical thinking. Captain Smith's distinguished military career includes holding the positions of Squadron Commander deployed in the USS Constellation, Senior Instructor Pilot, Top Gun Instructor, and recognized expert in air combat operations. Captain Smith has over 44,000 hours of military flight time, mostly in supersonic frontline fighters. During his airline career, Captain Smith attained captain qualifications in all modern Boeing airliners, including the ultra-modern B777. He was a line check captain on the B767 fleet. Over the course of a 40-year flying career, Captain Smith accumulated more than 25,000 flight hours. Assigned as the chairman of a government-sponsored Blue Ribbon Task Force, Captain Smith was directly responsible for the top-down redesign of airline pilot training programs for all U.S. airline carriers. This effort represented the first successful attempt to develop targeted training programs designed to improve the critical thinking skills for airline pilots. Captain Smith has received numerous military awards, including the prestigious Meritorious Unit Commendation, recognizing his exceptional performance as Squadron Commander. He holds degrees in electrical engineering and mathematics and is a distinguished graduate of the U.S. Naval Aviation Academy. At this time, I will turn the presentation over to our guest speaker. Thank you, Captain Smith, for joining us today.
And it is nice to be here, Anne. Thank you so much for that nice introduction, and welcome to everyone out there that has joined us. It is an honor for me to present this series of webinars that I'm quite certain you will find quite interesting and hopefully enjoyable. I've enjoyed putting it together. Anyway, so let us see if I can, okay, so my system is working. Let me start off by saying that I am dedicating this series of webinars to Colonel John Boyd, United States Air Force. He lived from 1927 to 1997. We were not exactly contemporaries. I would consider John to be roughly a contemporary of mine. We actually started our flying career flying similar airplanes. John flew the Air Force version of what I was flying. All right, so let me work on my system here a little bit. Okay. Apologize for that. A little bit of a technical difficulty here, so let me start with part one. Part one of this discussion, we're going to talk about an idea that we call modern agility, and it's used to optimize performance in an uncertain world. And I might add here that in part one we're going to be dealing with some introductions and definitions of what we mean by that, but this is kind of catching on, and it's getting wide attention. It started off, as we will discuss in a moment, it started off in a rather confined area, but now it's gone pretty much global. All right, and most industries now are talking about agility in some form or fashion. We call it modern agility for the purposes of our discussions here, and it is now considered pretty much across the board as being the new performance attribute for all information-intensive systems. And as you will see in a moment, we're going to expand the definition a little bit in our understanding of what we mean by agility or agile systems, and we're going to add another feature to that, which we call adaptive systems too. Okay, so modern agility. We have a growing desire for more agile systems. These systems could be standalone systems, they could be human-machine systems. Largely, it's going to be human-machine systems that we are concerning ourselves with. And what does it mean by agile, and how do we get it? I recently had a meeting at the Pentagon, and that's all they're talking about. It's kind of amazing, right? They're agile and agility is like the big word now. It's also becoming very popular in large industries like AT&T, SAP. Also, I have just noticed that IBM is doing the same thing. So lots and lots of industries are kind of coming on board, and I think this is a very timely topic for all of us. And it's been rather fascinating putting it together. So we can say all major businesses and enterprises are now, in one way or the other, getting involved or at least becoming interested in this idea of modern agility. And now, so let me talk a little bit more about what we mean by that. All right, so modern operational agility. All right, now it began, most likely, it began in a very narrowly defined area which we call air combat many, many years ago. And within that narrowly defined community, which I was a member of, and did a lot of leading edge work in that area, maneuver theory developed. We developed the ideas behind agility, which included fast transients, event responsiveness, and so forth and so on. And the agile systems became pretty much front and center to how we engage ourselves in an air combat situation. Also, because of the work primarily of Colonel John Boyd, our ground forces in the American military have adopted it in a rather significant way, and they have shown very dramatic improvements in their performance. So we can say then that modern agility is the ability to react quickly to changing operational conditions. And so we will kind of correlate react with agile, and then we can say that ability to respond effectively to that which is mission critical is adaptive. So we can say that agile adaptive is kind of what we want to do, and then I put it in these terms, which are react, respond, and win. All right, so that's kind of the way I see this idea of modern agility getting a little bit more specific. All right. So, just to take this one step further, for our purposes here, we can say that agile and adaptive consists of the following ideas. Now, these are not all inclusive. You can add your own. All right. These are just some things that I have put down here to sort of like stimulate our thinking. Agile, I have included under that fast, quick, nimble, unburdened. Adaptive is first and foremost, in order to be adaptive, you have to have some kind of nonlinear system in place. All right, so linear systems are not going to be adaptive at all, and we can pretty much say that right off the top. Adaptive also means the ability to reconfigure, reconsider, or reevaluate. So that brings us to some kind of a definition. So we can say that operationally agile and adaptive systems, and again, these are largely going to be the human-machine systems that we have, and we can say that they are defined as possessing the capability to adapt to changing operational conditions so as to achieve mission success. Now, in addition to that, you'll notice that we are going to add one more attribute to this whole idea, or this cluster of ideas, and that's going to be quick reacting, or another way of saying that is the ability to be adaptive in real time. Okay, that brings us to part two. Part two is, why do we want to do this in the first place? And part two is basically describing for all of us the fact that we have some kind of a problem going on, and I think most people would agree with that. There are issues or challenges that we face in this modern world of ours, this information-intensive world. And so let's see if we can spend a few minutes on trying to define the problem before we proceed to some set of solutions. The first thing is that across the board we can say that, perhaps we can say this, although it might be a little bit hyperbolic, but we can say that most of our industries are in some form or fashion in crisis. And the crisis was developed by this notion that more information was better. And actually, more information did not lead, and has not led to, improved situation understanding. So something was missing, right? So more was not better. Operational performance is, in fact, across the board, not improving as expected. So we have lots and lots of, the graphic shows this, we have lots of data coming in, don't know exactly what to do with it, but the performance output did not improve. So what happened to the data? Well, that is a good question, and so we're going to try to deal with that in this series, right? Now, I'm going to segue into an actual case study because, you know, I want to sort of like take this out of the theoretical realm and put it into a more of an operational or practical situation so people can kind of understand what we are trying to deal with here. And this is an actual case study of an industry that I was involved with and very familiar with, right? And I was part of this solution team to deal with this particular challenge that we had in this particular industry. The industry indeed was in crisis, right? Fairly significant. And I was brought in along with a number of other key people to try to come up with a solution. The operational performance of this particular industry, which in fact was the commercial aviation industry, was deteriorating, right? Notwithstanding the fact that we had lots and lots and lots of data coming in, all right, but the performance did not improve. In fact, the performance was deteriorating. Now, I'm using here aviation as a case study. We could use others, right? There are other case studies out there that are very, very similar. There's an amazing case study done by Dr. Gawande for the medical community in his book, The Checklist Manifesto. Remarkable book. I would highly recommend it. Also, the automotive industry has experienced crises, and I could go on. And maybe your industry that is experiencing a set of challenges of how to deal with a growing amount of data coming in, and it produces, by and large, higher levels of confusion rather than comprehension. This particular industry that I am pointing out here was the major airline industry. Now, the industry expectation was continuous improvement over time due to modern digital technology in operational and training systems, delivering greater amounts of information to operational personnel over what could be expected utilizing electromechanical devices, and data-driven information systems became commonplace in the working environment. The assumption here was that more information you had, the better, and that did not prove to be accurate, as it turns out. So, on this next slide, industry in crisis. The actual operational performance, as I show on this graph, showed signs of deterioration. Across the board, all system components were new, advanced, state-of-the-art, and in place, but the operational performance was not improving. The system was not working very well, and we weren't exactly sure why that was, and so the study group was formed. I was a member of that, and improvements in operational performance expected by all concerned did not materialize. We had to fix that, and we had to fix it fairly quickly. So we could say, essentially, that the problem was that whatever we had in place in this high technology industry, the system was in fact not agile. All right, it did not have agility attributes. It was not in fact designed to be agile because we were coming from a different perspective. And so we had to change our perspective. We had to change the way we were thinking about things, and we had to change our problem definition and solution generation algorithms to figure out how we could then employ agile systems. So the problem was the system was not agile. The assumption was that everything could be accurately determined. All right, that's a fairly common assumption. It actually did not prove to be correct. So that was an assumption that was considered no longer useful. Since uncertainty was not a factor, agility was not an operational consideration. So, you know, agility really joins hand in glove with this notion of that we're dealing in an uncertain world. And so we have got to be able to, one, recognize the fact that we are dealing in an uncertain world, and we have to be able to deal with it in some kind of an effective way. So the nonlinear aspects of large-scale systems was ignored. And so basically what we had, and I'm trying to show this in the graphic here on this slide, is that we had a number of mission events that we had to deal with, and our ability to respond to these mission critical events was limited and truncated. And so we need to figure out how we could change that dynamic. Okay, so the problem, agile and adaptive was the problem. Systems often did not know how to respond to changing operational conditions, and when the system did know how to respond to changing operational conditions, it was often slow and ineffective. And I might add here that one of the key words that emerged from all of this stuff is the word decisive. And so the decisive character, or the ability to respond with agility and with decisiveness, became one of the key attributes of our performance model. Part 3, what was the solution? And so we're going to cover that now. And now, as I go through this, I want the folks that are listening here, or that will listen to the archived version of this, that this is a grand opportunity for all of us. And I'm going to propose some ideas, but this is not the sum total of the ideas. I want to stress the point that I'm proposing ideas to stimulate thinking, right? To stimulate out-of-the-box thinking, critical thinking, if you will, and get people really excited about this, because I do think it's an exciting area to get involved with, and I think it's something that that many of us could join together in taking us into what is now being called the new cognitive era. So part 3 is a solution which we want to stress is modern agility. You notice that I have I have put up here a World War I air combat scene, and I did that with a little bit of tongue-in-cheek because these were not, of course, not considered at this time to be modern systems, but back then they were. All right, solution is agility. Okay, and what that means is preparative systems to adapt, the ability to accurately predict, have graphically depicted. You can see the current event, which would be shown at A, and the ability to predict this particular agile maneuver is key to success. So you have to be able to figure out what is the future, or what is the likely future situation given that set of events. And I might add that there are a growing number of very good prediction algorithms out there that, and of course, I've been directly involved in that for some time. I have listed some of them in the textbook that I have recently, that's been recently released. That has a particularly interesting catastrophe prediction algorithm in it. All right, so moving ahead, components of an agile system, predictive models. All right, we talked about that. That's very, very important. All right. In addition to predictive models, all right, what is that supposed to do? It's supposed to, predictive models and the decision support system is supposed to help us perform. And so it really needs to flow into what we call a set of performance aids, right? It just cannot exist out there in the ether or in the cloud. It has to then find its home, all right? So the home base for all of this stuff, all of this more intelligent information that's flowing in, improved situation awareness, and all of that stuff, it really has to flow someplace. And And this is what we worked on very, very hard in my industry. It flows into some kind of a performance aid so that we can optimize the performance as we go forward in these large-scale systems. So, specifically, and I'm gonna just segue very, very briefly into a specific case, right? And I'm doing that to just show you that this is more than just, you know, just esoteric thinking and more than just fluff. This actually did, we actually used this in an actual case, right? This agility. And that was in what we call the takeoff operational phase of a particular flight operation. In this particular takeoff operation, the circumstances were very, very challenging because the operation was being conducted at a terrain critical airport, and we needed to have in place an agile system to be able to deal with cases in which the propulsion system was degraded, and it was degraded during the actual operation of a takeoff at a terrain critical airport. So, in order to perform these takeoff operations, we had to figure out whether the system was agile and was adaptive. In other words, could the system respond quickly and respond with purpose, which means could it adapt itself in such a way that it could present operational meaningful information to support or to enhance performance. In other words, was there performance optimization aspects and attributes that were part and parcel of the system? And the answer was no, they weren't agile and they weren't adaptive, and we had to figure out ways to make them so. And that's what we did. We worked on this area of agility and adaptability, and we got these performance aids in what we call mission critical performance aids. We got them up and running, and it worked amazingly well. Okay, so that is the end of our webinar right now, except for the Q&A and final thoughts. Before we get into the Q&A, I wanted to just mention a couple of quick things. Number one, I appreciate all of you participating in this webinar and hopefully the series. Hopefully we'll have a group that will be returning as we go through this series that we have that we're putting together. And the second thing is that, you know, I mentioned this before, and I think maybe it's worthy of mentioning again. This whole area of adaptive systems and agile systems, developing systems that are not ponderous anymore, that are not overwhelming, that are intuitive, that are smarter, or they're more cognitive, and this whole idea of the human machine interacting being efficient and effective and optimized. With that, I will complete my portion of it and then open this thing up to Q&A, and I'm going to turn this back over to Ann. Ann, how are you doing?
Good, good. So we just have a couple questions to address. The first one was, one of our attendees is curious about the future of large-scale systems in terms of continuous emerging nanotechnology.
Okay, that's a good question, and I'm not probably not going to give you a direct substantive answer, but that is part of, if I understand the question right, we're talking about nanotechnology. That would be part of a broader construct, right? So nano is the you could say it's the theory of the small, or the smaller world, where there are ways to intervene into aspects of reality, aspects of a problem that we don't have yet, but we could, right? So I would say that would be part of our bigger picture, right? Part of our broader solution concepts. Nanotechnology is, in fact, in some way, it's fairly smart, okay? So these nanoclusters are not dumb. They are designed to be relatively intelligent in their environment, all right, in their microenvironment. And so that's part of this whole picture of cognitive systems, if you will, or more intuitive systems, or however you want to describe it, right? So I guess that's about as much as I can say at the moment, but it's a good question, and it probably needs, I would say, it needs a little bit more expertise from the nanotechnology standpoint, and I'm not one of those people. I'm more of a big picture guy, but that would be good. That would be a good question for some research group. All right. That's all I've got on that one.
No, that's fine. So a more general form of that question, in what ways do you think that technology will improve agility in the future?
Okay, that's another great question, all right? So when we talk about technology, we have to sort of like broaden our perspective, right? Now, when I say that, it requires us to expand our zone of comprehension and expand our ideas of reality. And so technology in the future is going to be different. All right, it's going to be a different aspect of our reality. It's not going to be necessarily robotics that we understand. It's not going to be these autonomous systems, although it could contain some of that. Technology in the future is going to be two things, right? It's going to be more robust, which basically means that wherever it is, wherever you employ this technology, it's going to exhibit robust characteristics, and that's a fancy word for meaning that this particular technology or set of technical components, will be able to respond more effectively to changing operational conditions. So it will be more event responsive. All right. Now, we can say that technology, if you will, is going to take on a different set of characteristics. And one of those characteristics is clearly, in my mind, going to be that whatever this technology does, first and foremost, this technology is, in fact, a solution generator. Okay? So it may do lots of things, but it's going to be directed, or it's going to be controlled, or it's going to be receive its purpose for being in the context of the reason for its existence. The reason for its existence is not to look pretty, but the reason for its existence is to be able to respond to changing operational conditions. In other words, to be a solution generator. All right, so you have a change, you have a challenge, you have a problem. All right, the change produces an unexpected situation, which could be defined as a problem, or in my profession, we call it a mission critical event. Right, so we encountered a mission critical event that was not expected. All right, how do we respond to that? All right, now the machine or the technology part of this equation is going to help us do that. Okay, because it can. Right, there are no technical limitations now to the machine being more responsive to the operational needs. There are none. What the limiting factor is, it basically is our imagination, our ability to imagine a solution that is not prototypical right now, or it is not a standard solution. Right, to the ability to imagine something outside the box, the ability to imagine something that is intuitive, that is innovative. That's the wave of the future, and we don't have any technical limitations to that now, because we have such great ability to design almost anything, and our ability to understand algorithms has increased enormously over the last 5 years and stuff like that. So I would say our technology will be much smarter systems, more intelligent systems, and this is one of the areas that I'm working on almost on a full-time basis, which is the mechanisms by which these systems can become more responsive, or more adaptive, or more agile, and therefore more helpful for us humans in solving these serious operational problems. Okay, did that sound reasonably coherent, Ann?
Yeah, absolutely. No, good.
What's that?
I said that was very good, definitely.
Okay.
Another question we have, is it or will it ever be possible to predict all the potential errors in a mission?
No, that's a great question. All right, and that's something that we, when I was redesigning airline pilot training for all the U.S. carriers, that's one of the things that we were, struggling with. That was our big challenge. There is to anticipate or to build in this on an a priori basis. So, very, very good question. So let me try to respond to that in hopefully in some kind of an intelligent way. All right. If you're looking at a complex operational environment, right, which generally exists pretty much across the board, aviation is one arena, but it's not the only arena that represents a complex operational environment. If you're looking at that particular environment, there's two things that stand out. Number one is that there is elements of uncertainty associated with it, all right? But, and here's the thing that we discovered, all right? Uncertainty does not present itself in a random way, all right? Now that's really the key. That is the key. All right, uncertainty may be there. It may manifest itself unexpectedly. I'm sorry about that, but I think you see what I'm talking about. But it is not random, right? These are not randomly generated events. In fact, there is no such thing. And I know sometimes it's hard to believe, right? Because we're kind of like not wired that way, or not trained to think that way, but that's what we've discovered. All right, these events that occur, these unexpected events, they do not occur in any kind of random form. If they are not random, then can we understand the pattern, the model, the performance model, The response model, is there some kind of model of reality that we can bring to bear on this challenge? And the answer is there is. Okay? Now, what we have done is we have then, and this was the big breakthrough in airline pilot training in general and airline and military pilot training in particular. The big breakthrough was to begin to understand what drives everything. Right? What drives everything in a planned operation is the event. Right? The event is not expected, or if it is expected, it is just generally perceived to possibly have an impact on the mission, but we don't exactly know where. Right? So the event then drives everything. And we then began to understand it better because the event can be classified. All right? And that was the key to our success. Once we began to understand the event in an analytical way, not in an ad hoc way, but analytically, once we began to understand it, then we could then, I'm sorry about that, but then we could formulate a set of solutions to enable us to effectively respond to that event or that event set. Event set is another fancy term for meaning a series of events that are sort of like connected, and often events don't occur in a singular way. They occur together or they're grouped together. They're clustered. We call those clustered events event sets for ease of understanding. And once the event set is understood in terms of its characteristics, then we can deal with it much better, right? So hopefully I've answered that. The great question. And if they have any more about that, you can always send me an email. All right, back over to you, Ann.
Looks like we just have one more. Is it possible that some agility methods can actually decrease performance?
Okay, could you say that again? You got a little bit of an echo, and I missed some of those words.
Is it possible that some agility methods can actually decrease performance?
Can actually decrease performance?
Yes.
Well, that's a good question too. I suppose so, because the agility has to be for a purpose, right? So if you have, and this kind of gets into one of the sort of like the big areas that I'm dealing with and I've dealt with over the years, is that an agile system, whatever its shape is, right? Whatever its form or shape, an agile system will come with it a cost, right? You don't get it for free, right? Agile system is, of course, desirable because you want something that's responsive. You want something that is capable of changing directions in a timely way, so as to avoid problems or avoid difficulties or even avoid catastrophe. But it also comes with it a built-in cost, and that cost is if it's agile, could it become unstable? Okay? And the answer to that question is yes. And that's the big challenge for us. We want agile systems. We want systems that can respond in an effective way. We want systems that are capable of, or another way of saying that, we don't want ponderous, overweight systems. We don't want ponderous bureaucracies. We want our organizations to be agile. We want our systems to be agile. We want everything, even our economy, right, in our trade policies. We want them to be agile and effective. But with that comes the challenge of making sure that we understand how systems can be stabilized if they become unstabilized, or how to prevent instability from occurring. Now, one of the things that we did is we of course built in a feedback loop, all right, in this large-scale system that I'm dealing with, that I've been dealing with over the past 30 or 40 years. We built in a feedback loop, and that is a part of the solution. It's not the complete solution, but the feedback loop is a good place to begin, so that you can get a sense of how you can keep the system stable. But that's a real good question, because that's the challenge when you employ an agile system. It could become unstable, and so stability becomes extremely important, and it becomes a major functional area, which we call stability management, by the way. And so that is a critical part of optimizing the performance of these systems. Okay, hopefully I did that question justice too. Are there any more, Ann?
That looks like that's going to be it.
Okay, all right. Well, I've enjoyed it. Thanks everybody for attending the webinar, and thank you, Ann, for all of your work behind the scenes and putting this thing together and making it happen and promoting it. And my hat's off to you. Nice job, and I've enjoyed doing it. So it's been a lot of fun for me, and hopefully others have enjoyed it as well.
Absolutely.
And we will look forward to seeing many of you again at the next session, which will be announced probably in a couple of weeks, right, Ann?
Absolutely. Yep.
Yep. Okay. All right. So I am finished. And again, thank you, Ann, for everything. And I guess we'll close shop, right?
Absolutely. I just want to also remind everybody that today's session is recorded, and all attendees will receive a link to access it directly. And yes, thank you so much, Captain Smith, for the wonderful presentation as normal. And thank you to all of our attendees for taking the time to participate in our webinar. As Captain Smith mentioned, we will keep you updated of future symposiums, and we hope to see you in attendance at those events as well. Take care, everybody.
Again.
Have a wonderful day. Thank you.